Good morning, everyone. Now we are here with our guest, Mr. Caboni, and we'll ask you to introduce you a bit, just to know who you are, what do you do for a living, and why did you choose Python as a favorite language?
I can use my own microphone, I think. So I won't spend a lot of time talking about myself, not now, later. And I've been programming Python for the last, I think, 12 years or so. And it's very difficult to me to say why I chose Python, because I couldn't imagine doing without it. Actually, it was quite incidental, because I had to find an open source application server, and Zope was very big at the time, and so I installed it, and it came with close to no documentation at all. So I just went and looked up the code, and I was actually able to understand the code without knowing the language. From that moment on, I was totally hooked. So that's my story. And I have been programming Python in almost every possible situation, and doing Python advocacy, because I just can't think doing something in Java or something else. But I think it's enough about me. And just one more thing, I do this for a living, so both Python programming and training. So if you happen to like this training, I'd really appreciate it if you could tweet some about it. That's my Twitter handle, if you want, if you like.
Oh, not just that. If you can go to our site, Europython.eu, if you can go. I have to show them a thing. You can actually vote even inside Europython your favorites. Okay, on the top you see mobile guide. You click there. Okay. Then you can download a mobile application and vote your favorite training tools and so on. So if you think that he deserves a good vote, rank him high. So next time we'll give him more space and try to have him doing more activities. Okay? Okay, now I leave it all to you.
So, this one was actually the most voted training of all. I'm not saying this to brag about it, because I don't think it has much to do, if anything, with my own merit. I think it's because of the topic. And I think there are about another dozen, perhaps, maybe more, between talks and training about testing this year. Why? I think it's because the topic starts to be perceived as important by the Python community. So this will be an introduction. So I'm not expecting you to know about testing at all, but of course it's no harm if you do. What I'm expecting from you is you to know how to program Python 2.7. You don't have to be Alex Martelli or Raymond Hettinger. I'm not either. But you should be comfortable with dictionaries, lists, and for cycles, whiles, the basic stuff. I decided to keep the examples quite simple. So when anything strange or weird or idiomatic comes up, I'll just talk about it. And I'd like this to be a bit more of a dialogue than a monologue. So if I'm going too fast, which I tend to do, or too slow, or you don't understand some obscure feature I'm using, or I'm doing some mistake, please tell me. I expect you to know something about object-oriented programming. I'm not talking about technical or academic stuff, just you know what a class is, what an instance is, how to do it in Python. Is everyone okay with this? Okay. And this is another set of expectation I have from your computer. How many of you are using Linux? Quite a few. OS 10? Windows? Okay. No, it's perfectly okay with Windows. Just in the end of the talk, we will have one single tool, which I don't think compiles with in Windows, unless you're maybe a mean GW wizard, you might want to find someone else and go look with them. I'm sorry about that, but it just doesn't work with Windows. But it's only one topic in the whole talk. And we will be using pip, which is a quite good package installer for Python. So if you don't have it, I think you should install it. It's quite... This should work almost anywhere. If you're using Debian style of Linux, just do apt-get python-pip. Okay.
What if I'm using Python Anywhere? Is it already there, or?
I don't think so, but
okay.
I don't think it would be useful because it's a command line tool to install more
okay,
stuff.
Okay, no need. Okay.
And so, okay.
I think you can install Python packages with Python Anywhere. You open a console first.
Okay, I'm not very proficient with Python Anywhere. I'm just keeping it like a last resort if everything explodes in the world. And, if you're using macOS 10, I strongly suggest you to install Homebrew. We will only need for installing one single tool in this during this training, but it's fantastic. Unfortunately, it's made with Ruby, but that's the actual installation. So you can, or you can just, use Google Homebrew Western. We will need this after the coffee break, but if you want to go and install it, it's okay. So, an introduction. So let's start with the basic. What is testing? What is testing? Anyone? What does testing mean for you?
Finding and squashing bugs.
Yeah. Well, I mean, let's put it in a general way. Testing is about looking if your code works as expected. Sometimes the difficult thing is knowing what exactly do you expect from your code, but that's another question. And we are all doing testing anyway. Every time you just launch your program to see if it does what it should, that's testing. So the question is not about testing or not, because unless you never fire up your code, you're already testing. The matter is, should we try something more structured, use some tools maybe? Is it worth it? It's, testing, it's often perceived as time-consuming and boring, especially boring by us programmers and time-consuming by managers who are telling we don't have 10 more man-months to do testing. Is it worth the trouble? I think it is. Let's see a few use cases of recent bugs. So 2010, Toyota had to recall about 400,000 cars, previous cars, and it was quite a costly operation, $2 billion. And this includes both the actual recall and the cost of course, the commercial cost, the image cost for Toyota. That wasn't the first recall either. But this one was caused by a software bug in the braking system, which is, I think, quite important for a car. Of course, a car is about going somewhere, but you'll want to stop. A bit far away from us, Mars, I think you have heard about this. 1999, wonderful space research program goes absolutely destroyed because of a very silly bug, just a mismatch between imperial measures and metric measures. So, when you enter an atmosphere, you can't just do it at any angle, at any height. And this was a fantastic, I think it was the most expensive firework of history. And the last one is on a bit more, serious, because this particular bug has caused about 8 to 21 deaths. I say 8 to 21 because it's not always easy to see why patient died. So what happened was that because of a software bug, radiation cancer patients were irradiated with 2 times the amount of radiation it was meant, and it's absolutely dreadful. And I happen to work in clinical research and clinical informatics for a few years, and I think this is the most scary website I've ever seen. If you want to see what software bugs can do, go here. But even if it's not, a question of life and limb, they can be quite costly. So yes, I think it's worth the trouble in general, because the numbers nowadays are so high. Even if you do a trivial web, I don't know, web application, web application, we probably, if you publish something on the App Store, on the Google Play Store for mobile devices, you'll probably have thousands of users. So everything you do can be very costly to you as a developer and to your users. So I usually try not to use the term bugs, because it reminds of the cutesy image of this taped butterfly on the logbook. But those were other times. Nowadays it's not anymore about moths. It's about if a car explodes as soon as you start, you wouldn't hear it being called as a bug, but as a defect. So that's what bugs are, defects. It's all software not doing what it should. And this happens because you suck at programming. But by you, I mean me myself and just everyone, included Alex Martelli, Guido van Rossum, because, I know, but I'm sure they agree, because even the masters of programming, and I just cited 2 masters of programming, do dumb, stupid mistakes. And you'll find that the more experienced a programmer is, the more serious about testing he or she is. Let's see how even doing something absolutely trivial can be tricky. So let's do something simple. Let's say we will calculate the average of a list of numbers. Very easy. Okay. Do you know about this asterisk here? Every one of you? Okay. It just accumulates every argument that is passed to this function to a list. So you can call it average 1, 2, 3, 4, and you'll find inside the function a list named numbers. Okay. So, well, it's easy. Python has a sum function that returns the sum of a sequence. So the average is the sum divided by the number of terms. So we should be done here, right? Oh, I didn't redone anything. Really made a mistake, even if it wasn't the intended one. Okay, it works, and even works with negative numbers. We are great. It's working absolutely That's not the average between 0 and 1. First bug. because in Python 2.7, by default, the division between integers returns an integer. So that's a bug. Every time we have a float average, it doesn't work. So there are a number of ways of doing this. Let's say this is one way, or you could just do this. Okay, it works, but what about this? Zero division error? How would the user react to a zero division error? So you see, even something incredibly trivial like this tends to be tricky because programming is always about details, and things can quickly go very wrong even with the most trivial of codes. That's why, because programming requires absolute perfection because the machine is perfect in its own dumb way, but we humans are not. And all in all, I'd say that software testing is pretty much like medical testing, blood testing. If you suspect something could be wrong with you, especially if you maybe by age or gender or something else in a high-risk class, you'll do some testing to do if something's wrong with you. The only difference between medical testing and software testing is that with software you're quite sure something's wrong with your code. Something is always wrong. And so that's why. We will see some other reason to test later. But now, often we just do testing in the most unstructured way, like, let's save it. Something like this. Maybe we should have an argument. Okay, there is the bugged version, but it's not important because oftentimes we just do something like this. If name is main, and we'll just throw up some print and so on and so forth. Well, this is a way of testing, but it's not very convenient. It's very limited. Another way of testing with Python, which is a great way actually, is just doing what I was doing previously, just typing stuff in the Python console, which is great, but it sort of gets lost after you close the console. So it would be very cool if there was a way to save what you do in the console and execute it multiple times. Well, fortunately, there is, and it's a very cool Python module called doctests. Did you know about doctests? Okay, doctest just does what I said. It just reads text, which has the same format as the Python console. So let's try to do something for a simple arithmetic operation and just paste it in a text file. You can just cut and paste from the console right away. And let's save it. Let's call it first.txt. Save. Yes, I'm sure. Yes, txt. Okay. Then we can just ask doctest to execute this console session for us. It goes like this. If you're using, is any of you using Python 2.6? Because this won't work. Because it hasn't, it can't run modules from the command line like this. So you should maybe try installing 2.7, or I'll show you another way. But this is much more convenient. So how did it call it again? I don't remember. First.txt. Text. Okay. So Python. -m, that means execute a Python module. The module is doctest. It's in the boundaries. You don't have to install anything. First, well, that was quite nothing, which is, you know, how Unix tools tend to work. If everything went well, they say nothing. So let's say we do something wrong. This shouldn't be what really happens. That's better. So what happened? Doctest modules tried to actually replicate the console session we had stored in the text file, and it just checked that the expected, what we said was the expected value was 8, but when it replicated it, it wasn't 8, it was 7. This is cool because, you know, we can do every kind of test. If we save, let's just save the average example in a separate file. Average numbers. Return sum of numbers divided by their number. Well, let's do like this. So this is the version that's supposed float. We just can do something like this. Actually, the best way to produce doc tests is starting up in the, you know, in the console itself. So from average, import average. Of course, when we are, yes?
Sorry, I'm getting a very funny error.
Oh, that's wonderful.
It tells me your test failed. I put 4 plus 3. I was supposed to return 7. It says failed, expected 7, got 7.
Oh, may I? This is peculiar. Can I see that text file?
So we are in streaming, so when you are
Okay.
asking a question, it should be good to be with my mic. So
Okay,
that
okay.
people-
I had to see it. Actually, I've never seen anything like that. It's very weird.
I'm getting an error when I ran just a simple doc test file from before. I'm not sure why.
What? I think I think you could have written something wrong in. Can you check? Okay, let me come. Syntax error was.
I guess.
Is it only for 3.2? I'm thinking if it only works for Python 3.2.
No, it's 2.7.
2.7 as well?
How are you calling this? No, you don't have to put it in the .py file.
No,
You
it's
have.
not. It's in text file.
Text file.
Okay, and how are Python?
That's right.
This is very. This is very weird. Okay, some of you are getting very weird errors, which I've never seen. Which, of course, actually, I'm sorry, but I don't think we have time to see any one of the single errors. It's very weird. I just can suggest you to try, I don't know, doing another text file.
There is a bug, something. If you put a space after the 7, you will get...
Yes, of course. That's what, okay. I just forgot to say that because I would have said later. But be very, very, very careful about extra spaces. Because if I do this, or even this, it won't work well. I think this is the error you got. I think you had extra space. Why? Because doctest just does something very simple, which is text matching. And we'll see later then we do have a couple of options to deal with this, because it can be a real pain. So be very, 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 very sure not to include any extra space, including white space, because you know, okay, there are two different strings for him. Did this solve your problem as well? No. No? Okay, let's try to go on, and maybe later during the coffee break I'll try to see if, let's hope the other examples would work. So yes, and what it does, as we have just seen, is just some simple text matching, which can be a pain. Sometimes we must be really, really, really careful about white spacing and whatnot, but can be really powerful. Of course, when we are testing our software, we won't probably be able to produce the entire doc test using the console, because maybe we won't have already implemented something, but we can just start grabbing it and then continue in the text editor. Another cool thing of doc test, it completely ignores everything that doesn't look like Python console. So I can put random text here, and this should still work. No, this is too complex. Text. Okay, it just ignores it because it doesn't look like Python console stuff. It's not Python console stuff. And this is actually what makes doctest really, really cool, because in a single text file, you can have your module documentation and an executable test. So, for example, let's try with our average UI. This is a doc test for average PI. Let's import it. So from average, import average. Okay. Okay, so we'll this is a good practice. So we just found a defect in our simple code, and we'll write a test right away because we must be able to catch it. Okay.
Can you put text between two?
What stupid mistake did?
You put text between two shared inputs from average, import average, then test.
Oh yeah.
Test, and then average you cannot.
Sorry?
Let's test if it works correctly. You cannot put it here.
Oh yes, of course.
It's
Okay.
expecting from.
Yeah. So,
the-
yeah. Yes, of course. If it's expecting it, of course, you must be always careful about this because if you do, if I didn't even realize, if you do this, of course, since it thinks it's like a Python console, its expect is like a return value from this statement, which is not. So okay, let's have it. There must be something very wrong in our code.
You need a parameter before 1.0.
Sorry?
You need to enclose 1.0 times.
Oh yeah. I'm sorry. I'm a bit tired today. But this is actually this is cool because it shows how it shows how easy it is to go details wrong when you're tired, when you're in a hurry, when you're doing a training like now. So, but there was something interesting when it failed. Let it fail again. Okay, one of two items had failures. Why? Two items? Do we have two tests? We do, because for duck tests, every single statement we have is a test, which sometimes is not very convenient because every single import, every single, if something wrong?
Well, no, something good.
I can't hear.
I think I worked around the invalid syntax problem by putting what you have, preceding it by a line of triple quotes and then a line of triple quotes afterwards. That seems to make the problem go
You're
away.
doing it in a Python file or just a text file?
Python file.
Okay, we'll go there later. For now, we are just writing text files. Okay, so let's see it right now. Okay, this is cool. We can just write a text file having a story. We can continue like doing other tests.
Just going quickly, so if you want to,
Yeah.
if you want to include comments,
Well, you can just
I guess just make that.
yes, because from as we've seen before, it's just after this it's just a console session, so it will. Oh, by the way, I don't know if any of you use IPython. You do. If you know Python is fantastic, but it's a bit tricky to use when you're just copying and paste from doc tests. Fortunately, because it's different. If you just copy and paste this on a doc test file, it won't work. But it is cool. You can just tell IPython you want to use it to do doc test stuff, and it'll revert to the usual. And when you're done with it, is a toggle. So okay, so this is very, very nice, and we are. I really like doc tests because it feels like cheating, because you are doing two things in one. You are doing documentation and you are doing executable testing. To get our documentation, we can just use the PyDoc tool. Just give it. No, okay. I want to show you something else before, because like this is cool, but it's still a text file. So we have all module and a separate text file testing it and writing some documentation. Sometimes it's nice, but in Python we can do more. You know about docstrings? Okay. Docstrings are a cool feature of Python. When you do something, everything just like starting a module, starting a class, starting a method, starting a function, you can just put a string without assigning it to a variable, or just put a string there, and that will be the docstring of that object, which means that is mapped to the magic $doc attribute. You'll find that this is used quite widely in Python, so okay. I think you already knew about this, but I just thought to quickly recap it. So what we can do is put doctest string in docstrings. In this way, we can have both things nicely in the same file. So when we distribute this will be a good example for anyone calling the function and wanting to know how it works, because it's just like a console session. On the same time, it's executable documentation, because the only thing that's worse than having no documentation is having wrong documentation. So this is a very, very, very trivial example, but in the practice it happens very often. You do something, the code, you document it because you want to be the good programmer, then you change the code and you don't change the documentation, and the user ends up being very, very, very confused. Okay, for those of you who were using Python 2.6, you can't use the Python -m option. I always get this wrong. Fortunately, there is another way to I think it's test mode. I never can remember it. Let's try. Okay. So what we did here, let's see it. We just put our test instead that in a separate text file in the docstring for the function. Then we use this snippet to execute programmatically doc test, which is cool for those of you who are using Python 2.6, because this will work. And when we call it, the test gets executed like they did with the text file. And notice that here it was wrong on purpose, and here again it just shows us that doc test doesn't know. Doc test doesn't know about the semantics of what it's doing. It just does text matching. So the string 1/5 is different from the string 1/5.0. You have to be a bit, careful with this with doc test. Now we will see that there are options to help us with this mechanism in some cases. But anyway, so we just got something free, which is documentation. Let's see it. PyDoc average. This is a nice console output. It just took it from our docstring. Can you still hear me? Okay. PyDoc has another host of cool options. It can run on a web server. PyDoc, not Python, of course. And it will just run a web server, so let's go. And average. This is completely free.
Can you show me the command line?
Oh, of course, sorry. As I say, they tend to go too fast and do a lot of stupid mistakes. Okay. PyDoc -p, a port number, and it will automatically start a web server using that port number in your machine, which has the complete documentation of your installed module, included those in the current directory, which is in the Python path. So you should fire up your browser, and you should find our example, and it shows the docstring. So this is cool. I actually love this of doctest because if there are two things that programmers usually don't want to do, they're testing and documentation. And here we're doing it at once. Okay, so yes, doctest is cool. It's very nice, but the fact that is in its root just a text matching engine can get in the way with programming, because there are a lot of instances where we can't be completely sure the text will be exactly the same every time we execute it in every machine. Can you imagine a situation where this would be a problem?
Different architectures.
Exactly, different architecture, which usually is a problem with floating point numbers, because you can't be sure, and actually you are sure that it's not the same on 32-bit machines, 64-bit machines. It's quite tricky, and so if you want to test something like this, okay, this is probably safe because it's this is probably not safe. So if you take this string and put it in a doxer somewhere, because maybe you're doing some calculation in your function, and it will probably fail on different architecture on different machines. Fortunately, doctest has a couple of cool options to work with this. Okay. Yeah.
Where do you find PyDoc?
PyDoc should be installed in your system because it comes with batteries. It should be, usually it's in some binary directory that already is in your path, so you should be able to just write PyDoc. It could be a Windows thing. I'm afraid I'm not. Are you using Windows? I'm afraid I'm not that proficient with Windows in this regard, but maybe you'll find in C Python 2.7, I think, /bin or /scripts.
Okay,
It's there.
there's a Stack Overflow. There's a Stack Overflow issue about that.
Wow, nice.
No, you can have it, but you have to do something extra. Just search for get PyDoc command working in Windows.
Okay, sorry. I'm sorry, I don't use Windows very much.
Are you sorry?
No, I mean, okay, I'm not sorry.
Sorry for us.
Yeah,
For the Windows users,
I found the I found the PyDoc. It's in Python tools scripts.
Ah, tool scripts, right. That reminds pains of the past. I actually had to use a lot of Python on Windows and driving Excel via the COM module, and I removed it all. Anyway, this is the spirit. As you have seen, I do a lot of stupid mistakes, and I don't know everything. So if you help me and you help each other, this will be a lovely training. So what were we saying? Yes, about the fact of this is not safe. Another thing that is not safe is dictionaries, because you put keys in dictionary in a certain order, but you can't be sure how the dictionary will be printed. And actually, there are a lot of situations, if you think about it. Time.time will be different every time, random numbers. And fortunately, doctest has a lot of options. And they are invoked like this. We put a comment in a line where we execute the statement before the result. We just write doctest, and here we put the option. This is one ellipsis. That means we can do something like this. 0.74 and so on. Python -m doctests. First. No. Oh, okay, I'm on a different machine. Okay, it works. Because it just a very simple regular expression where the ellipses mean everything, which is cool. Another option we could use when we have something that we know that fails. Maybe we are just testing something that we could implement, but we're not very sure about it. And it gets in the way when you have dozens and dozens of tests, seeing stuff again and again that you already know it won't work. It could be a pain. So there is another option. Like this. It didn't fail because we said, okay, skip that one. In general, I suggest you not to skip tests, and we'll see why, but anyway, it's another option. And let's see something else. Another area where I could expect things to go a bit, to be a bit peculiar with text matching is exceptions, because, when you raise an exception, it does give us a lot of context-dependent stuff. So we could imagine that doing this in doctest would be a problem. Sorry, I'm going fast again. Did you see what I did? Okay, I just made Python raise an exception in the console. Just an exception, but you can raise type error if you really want. Okay, what we expect is this will fail in doctest because this will change over time. It won't be always line 1, and if it gets executed from a file, the file won't be standard input. So let's just try. We just copy this and paste it in the editor, and this should fail. But it doesn't. Thankfully it doesn't, because since since testing that some of your method in some circumstance does raise an exception is an important part of testing. If we see the average method before, for instance, we should make it so that if the user didn't pass any number, we can do it in two ways. So if the list is empty, we raise something better than that zero division error, because it's very clear. So we could be say, okay, we shouldn't be raising exception, which is very bad practice, but it's okay. So in this T-shirt is not microphone proof. So this is now is a feature of a small function, so we should test it. So if we fortunately doctest knows about exceptions, right? Because it's very, very common to test them, and it ignores, even if you don't say ellipsis, it ignores a part of the output. I'd like to give you 1 or 2 minutes so you can play with this a bit and figure out what part of the exception exactly gets ignored. Clearly it's ignoring some part of the text because it's not the same, but which part exactly? In the meantime, I will. Okay, the best method to see is to try it. So let's try to add random garbage here. Exactly, yes. It ignores this, but it doesn't ignore this. So, because the second line is always context information, and the traceback can be longer than that, and that's always contextual. So it's always a good idea to ignore this. But if we want, we can also ignore the message, because it can change. The message given to the user can change, so we just want to make sure that that specific kind of exception, let's say type error or exception or whatever, gets raised, and there's an option for that, which is so now it fails because the message here is different from the message here. Okay, it's not what he expected, but we can say it ignore everything except the type of the exception, which is an option which I don't remember, but it could be ignore. Now let's see the docs. Doc tests. You see that? Ignore exception detail. I never remember it. So if we do it, I must have done something wrong. Well, okay, anyway. Okay, I have put it in the wrong place, of course. Okay, we're saying doc test. We really don't care about the stuff, the message. We just care that exceptions, that specific kind of exception get raised. And there are a lot of other options. You can see them in the docs. You can just say, for example, don't accept one for true. If I say true, I want true, and so on and so forth. But I won't. Okay, you can just look up it in the docs. So to quickly recap what we've seen with doc tests. Doc tests is very, very convenient because it's, as I said, it's like cheating. You have documentation and you have executable test. And what's more, you have executable documentation and tested documentation, meaning you're testing both your code, your underlying code, and the documentation itself, because if the documentation is not in sync with your code, doc test will fail. And okay, I have a little exercise for you, for those of you who want to try it, which is very simple and useless because the math library already has it, of course, but it's just a simple something to try and to try some doc test on its own. And we will use it in a few minutes with unit tests as well. So the factorial of any given natural number is defined in a recursive way formally, but the example makes it clear. The factorial of n if n times n minus 1 times n minus 2. So the factorial 5 is 5 times 4, 5 times 3, etc. So let's try to implement it and do some doc test on it. Let me create it. Okay, probably the easiest way to do it is to just follow its recursive definition. I say the easiest way, not the best way. But it can good enough for what we... Okay. So, if n is 0, is 1, else, let's see it again. Okay, this will fail with large values of n because we're going to recursively call the same function we have defined. Of course, Python have support for recursion, but it has a limit because when you execute recursive function, everything gets put in an area of memory in a stack that has its own space, or everything will flow and you'll see bytes flowing in the floor. And but it's not important right now, and we can see an iterative version, but this is simpler to understand. So let's try documenting it. Oh, by the way, you can put docstrings not only after function but after modules, and it's a good practice to do so because usually you will have more than one class or function in a module. So this is a useless module. Okay, so you know, ideally when you test something, you should have a reference. Okay, so if we just call a Python console here, executing this function, we are not testing actually anything. We're just testing that its results are the same as its results. We should find a way to calculate a factorial that we know it works and use it for comparison. This is what it's called an, where is it? No, this number thing. This is what it's called an oracle. An oracle is when you have to test something, maybe something as simple as a factorial or just a calculation, and you can't test it against your own input. You're not validating your input with your input. It's not very correct. So you have to find the right number somewhere from an oracle. And the oracle can be just anything. You can just try it by hand, which with factorial could be feasible for low values of n. Just in our case, we could call factorial from math, or we can I don't know, use for instance Wolfram alpha, which if you don't know it is a very cool site that lets you do stuff like this and much more. It's mathematics on the web. Okay, so this is very important. You know, for factorial is trivial because it's a very well-known algorithm, but you shouldn't be using your own output because it's, of course, you have to test it. If there's, let's say, a bug for factorial of 0, you'll never find it. So, okay. We should put some description here. We should put some description here. Okay, we're testing so O factorial against the result from the oracle, in our case Wolfram alpha. We're sure, of course, every software bug, but the oracle is that's why it's called oracle. It only tells the truth. We're testing our own function against a known good value. And another thing which should always do when testing is testing of boundaries. You know, you always have in your code 0 or maybe the maximum value. In this case is 0. Because now it works, but if we change implementation, if we get something wrong, most probably it will be boundaries. Okay.
If you want to test that string is passed instead of a number.
Sorry?
What if you want to test that the string is passed as an argument? I think it raises an exception.
Yes, in this case, okay, yes, this is, well, we just should ask what would we want to happen? We'd want probably to raise a type error. It's not implemented right now, but actually it shouldn't accept a lot of stuff because factorial is only defined for natural numbers. So we should, for example, but maybe we'd like to accept float numbers that are just you can convert automatically to integer numbers, and so well we can add those tests. Actually, this was meant to be later, but this is what test-driven development is. Aside from big words and philosophy, can I have some glue or a nail maybe? No, not a nail, maybe a glue. Maybe glue. No, it's... Okay. Am I too loud? No. Okay, so this is what test-driven development is. It's, we're just starting to use tests to, in advance, even before we implement the features, which is very nice because now when we execute this test, it will fail.